Hi Spring fans, welcome to another installment of Spring Tips. In this installment, we're going to take a very quick whirlwind tour of some of the latest and greatest features in Spring Framework 6, whose first release candidate just dropped. Basically, it's feature complete and we can talk about what's supposed to be in there. Things might get a little bit more refined, there might be polishes and bug fixes and this, that, and the rest, but barring anything substantial, that is what will get released when the final thing is released in about a month's time, at the end of November 2022. And obviously Spring Boot 3 will build upon that and give us even more of the nice integration that we expect with all the ecosystem libraries. There's a lot of stuff in Spring Framework 6, but a lot of it is also hidden behind the scenes. It's foundational, just an incredible amount of work required to get Java 17 going, to get Jakarta EE compliant APIs going, and to get the AOT GraalVM foundational infrastructure in place for native image support. All that stuff is there now and it just works 99% of the time, but you will need to be aware of some things and how they might impact your code. In this video, we're going to just take a brief walking tour of some of the features in Spring Framework 6, and we're going to do so in terms of the Spring Boot 3.0 snapshots. Obviously, by the time you watch this, it's very likely that there will be a release candidate or indeed a finished version of Spring Boot 3, and you can expect this stuff will just get better in those succeeding releases. As always, my friends, I'm really excited about this, so let's just dive right in and look at the code, okay? We'll go to start.spring.io. We're going to build a new application using 3.0 snapshots. We're going to call this the service. We're going to bring in the Tomcat web support and the Spring Boot actuator. And that's it. And we're going to use Java 17. Obviously, a big important part of this new release is that Java 17 is a prerequisite. It's the baseline supported version of Java. There's a lot of things we could say about this, but for now, let's just dive into the code. We'll enter presentation mode. Okay, a few things to consider. First of all, our pom.xml is basically the same as it would be for any normal Spring Boot application. Obviously, here we're doing work against milestones and snapshots, so we have those repositories in our build, but those won't be required when Spring Boot 3 and Spring Framework 6 with it go GA later in November of 2022. So basically, this is your build. This is the build you can expect to have in production. And it's trivial. I'm just adding the web support and observability support. And here, we're just going to build a simple HTTP service. We're going to have an entity called a greeting, which will have a message. Okay, and I'm going to create a greeting HTTP controller. And we're going to have an endpoint that returns a greeting when you ask for it. So greetings name, greeting. Okay, we'll just call this greet path variable for the path param there. Return new greeting, hello, right? And then voila. Okay, now there's our basic controller. Make it a REST controller. I want to be a little bit careful about the kind of data that we take in. So let's say if string utils has text name or name.caret0 is uppercase, then we want this to be like that. So if it's, let's see, we want a negative, right? So either if it has text and the character is uppercase, right? So if it's not that, either one of those, then we care. So we'll say throw new illegal argument exception. The name must start with a capital letter, okay? And now we've got ourselves a little bit of error validation, not too much, but it's nice to have that. And what I want to do is I want to extract that out into a single place where I can, handle the error handling in the application. So of course, if you know about Spring Frameworks, remember, Spring Framework is geared towards not just small apps, but also enterprise scale apps, right? And so there's lots of mechanisms and lots of ways to centralize and let the framework handle various aspects of the code. Here, I'm going to just create a problem detail error handling controller advice, okay? And I'm going to create an exception handler. And this exception handler is going to be involved when there's an exception of type illegal argument exception. And we're going to actually return a response. So actually, we could return a response entity of something. In this case, we're going to return a response entity of problem detail. Or you could just return a regular body. That might actually be just as convenient, right? So I can do that as well. Var PD equals problem detail. And I'm going to say for status and detail, right? So HTTP status code dot value of 404. And, the name is invalid. There you go. Okay. So return PD. Now, of course, you could change this, set status, set title, set detail, set whatever. You could also return a response entity if you wanted to programmatically set things, or you can use annotations like response status, HTTP status, bad request, or something like that, right? You could do all that kind of stuff. But either way, the important thing here is that we're centralizing all the error handling, and we're using a newly supported thing in the Spring ecosystem called problem detail. This is new in Spring Framework 6. This problem detail satisfies an RFC. There's actually an RFC 7807 that is intended to provide a consistent way to represent errors, and that's now supported out of the box. So you could, of course, return this problem detail from your method directly, but it's good practice to centralize your exception handling logic in an example. And so this controller advice would apply to all controllers in the application. Had I copied and pasted this, or moved this method to the controller itself, it would have applied to all methods in that controller. So good. Now I've got a consistent way to represent errors. I might want to also, maybe I don't care about the type. I'm not going to inject the reference. I don't care about it. In which case I could just define the class literal there. But I do care about the current request. And so let's take a look at that. I've got an HTTP servlet request, right? Request. And I have attributes. I can say request.get attribute names as iterator for each. And, I'll just log out the attribute names because I want to make sure I understand what's happening when the application is running, right? So attribute name, and we'll say attribute name, okay? Attribute, yeah, that's the one. So it's actually just rename name. Okay, good. So there we go. There's my simple error handling logic. I'm just printing out the attributes if there's an error. And I'm doing that in terms of this HTTP servlet request interface, right? Well, of course, this is a servlet spec interface. I don't have to use this. Spring actually has higher order types that you can inject and stay indirectly above either Netty in the reactive world or imperative IO in the servlet world. But the point is I'm choosing to inject that here just so we can make a point. This type comes from Jakarta.servlet.http. That Jakarta bit is new. You might be familiar with the javax.servlet.http API of yore. But of course, a long time ago in a galaxy far, far away, Oracle ghosted the Java EE community, and that resulted in some outcry. And then finally, after 3/4 of a year or something like that, Oracle came back to the table and they open sourced the Java EE specifications so that the APIs and the specs could evolve. There's a little bit of a poison pill, however, in that they stipulated that all changes to these APIs had to happen in new packages. So basically, the only reasonable pragmatic thing to do was to move everything to a new package and then start evolving on top of that. So from a technical perspective, the Eclipse Foundation and the people working on the Jakarta EE APIs have done everything anybody could reasonably hope they could have done to make this transition as painless as possible. It's just a political perspective that makes it so painful, right? But that said, it could and more than likely is just a matter of find and replace, at least for your code. We've spent the better part of the last several years wrangling all these different ecosystem libraries and bringing them in to Spring Boot and re-enabling parts of the project that temporarily didn't work as we started to rationalize and sanitize all these different ecosystem libraries across the portfolio. So supporting libraries, things like Hibernate, things like Tomcat and Jetty and all that, they've also been updated, and so you'll see that even if we wanted to stay back, we really couldn't unless we wanted to risk being stuck on older APIs. And obviously, we don't want to stay back. We want to use the latest and greatest always. So there's our controller. There's our controller advice. We're using the new Jakarta APIs. We've got Java, what is this, 16 or 15 records, right? We got that here as well. And that's because it's supported now. Spring Framework itself is using Java 17 now as well. We've got problem details. This is a lot of stuff, and yet hopefully it's still very, very familiar, right? You should know exactly what you're looking at. Now, I want to observe this application, right? In order to observe it, I need the Spring Boot actuator. The actuator gives me instrumentation that I can use to understand the state of the application. So, of course, just for our demo, I'm going to include all the actuator endpoints. I'll show the details for the health. And I also want to enable problem details. I forgot to do that earlier, so make sure you do that when you want to use problem details with Spring Boot today. That should give me everything that I want. But now that I've got the actuator enabled, I want to take advantage of the ability to instrument it, and I'm going to do it using the new Micrometer releases. You see, another huge theme, another major shift in Spring Framework 6 is that we've reworked Micrometer so that it now supports both tracing and metrics. In fact, it supports it through a unified API called an observation. This API is awesome. It's clean, it's elegant, and it's, for a lot of use cases, it'll just be invisible to you. You don't even have to know about it, but it is there if you want to benefit from it, to use it. So, for example, here I'm returning a greeting. Obviously, this is just an in-memory thing where I'm creating a reference, on the spot. So there's not really any latency or any risk there. But let's suppose that I was doing some sort of database logic or something like that. Here, I could instrument one of two ways. One is I could say at observed. This is IO micrometer observation annotation, and that's fine. But I quite like this new static builder. So observation, create not started, and then you give it a name. So here I'm going to say greetings, name, okay, and then you pass in a micrometer observation registry. So observation registry, inject that into a constructor. There you go. Okay, this dot registry, and then we get to observe something. So here I'm just going to observe the production of creating that greeting object, right? Good. So there we are. There's our application. We're going to replace that with a Lambda, and there we are. Good stuff. So we've got our observability built in. We've got this new nice API that consolidates both tracing and metrics, so you can talk to backends like Zipkin and so on for tracing, and you can talk to different time series databases, things like Datadog and Grafana and so on, to visualize all that, all with the same standard unified API. And the nice part is that since this API now sits squarely as a dependency of Spring, right, as opposed to sitting on top of Spring Boot in the Spring cloud space, because all that lives now at this lower level, every library that depends on Spring can also in turn depend on this, right? And ditto, third-party libraries that instrument using this new observation API, they get the benefit of being able to communicate trace information as well as metrics in a single standardized way. So this is very convenient. Also, we have a bridge. So if you're using OpenTelemetry, that'll also work, right? So we have one low-level API that everything, including Spring Framework itself, for all the common lifecycle events, will use. Let's go ahead and restart this. Okay, it's up and running. And let's go to the console here. Curl HTTP localhost 8080/greetings. And we'll just say Jane, okay, capital J, good. What about lowercase j? Oh, it's cached. So what about lowercase Bob? Uh-oh. Is my condition bad? When in doubt, good. Make it more clear, right? So I'm going to tease this out. If it's an uppercase, so if it has text and, okay, good. So if it's not good, throw that exception. Good, let's try this again. Rookie mistake. This is why we test in production. Okay, so terminal, lowercase. I get that problem details showing me the type. And by the way, this is usually a URL explaining the problem. I get a title, I get the status code, I get the name is invalid. I get the URI where it happened, etc. Good stuff, right? And if I go here and I do Jane capital, I get the message as well, right? So that works out just fine as well. And just so I can understand, yeah, that should have failed. Good stuff, right? So I can also then see that reflected in the actuator metrics. So actuator / metrics and JQ. And you can see things like, Tomcat sessions created, all that stuff, because it's now being instrumented in a low-level way. We have greetings.name and how many active requests we've got for that as well. So I can say, okay, give me metrics like this. And it shows, okay, are there any errors? None. There's the tags. I get statistics like the count, the total time, etc. All right, so I've got a service. I want to turn this into a GraalVM native image. That is just built in right out of the box. If you've ever used Spring Native, then you know that in order for that to work, you would have had to add a number of dependencies to the build, but it's no longer required. It's all just part of Spring Framework 6, another huge, substantial change in the foundational layers of Spring Framework itself. So Maven -p native -d skip tests clean package. Okay, so we're just going to build this, and it'll take about a minute, so we'll let it run. All right, there it is. So let's go to the target directory. And there's our application. You can see it is 72 megs. That's the entire application, Jerry, application code, Tomcat, all that stuff. It's in there. This is an architecture and operating system specific binary. It is created by using GraalVM's native image compilation mechanism. The benefits of this are twofold. First, yes, your application starts up quickly. Who cares? Oh, there's a port running. Run that. Okay. Don't care about that. I'm with my terminal. Okay, there it is. So it started up in 71 thousandths of a second, but much more usefully, if I go back to my terminal here and I look at the existing instance, what's the process identifier? The PID is 16151. Let's go to the other terminal, and we can run my little script here, Josh bin RSS by PID. This script does PS -O, and then it captures the RSS, the resident set size of the process itself as it's running, including all the operating system libraries, right? So let's just paste that, and it's taking 91 megs of RAM to do its work. So you put that in a Docker container, a very thin one because you don't need a full operating system anymore. And you've got yourself an application that'll run with very little RAM, 91 megs of RAM, right? That's less than a tenth of what most applications will take on the JVM these days. A large part owing to the fact that it's just running on the JVM, right? Just the JVM itself takes a lot of RAM. So this means you can now deploy, whatever, anecdotally, roughly for a lot of scenarios, but certainly not all of them, maybe 10 of these for every one that you deploy on the JRE. Now there are some drawbacks. There's no such thing as a free lunch. Obviously the GraalVM native image compilation, you don't have as many transactions per second. You won't have as fast a garbage collector. And so therefore that'll negatively and adversely impact your transactions per second, your requests per second, et cetera. But again, you can scale out and more than compensate, right? And still not exceed the footprint of what you were doing before. It also has no support at the moment for Java agents. So if you want to do instrumentation, well, of course, it's a good thing that that's now even more readily integrated into your application using Spring Boot and Actuator and Micrometer and the like. Yeah, it's a pretty good deal, people. This is good stuff. Now I've got a service. Let's go build a client very quickly. We'll go back here. We're going to build a client. And this time we're going to use the reactive web support as well. Let's get rid of the web support. I'm going to use Spring Boot. Do I need Actuator? No, I don't. Let's just do that. And we'll hit generate. Alrighty, client application. And all I'm trying to do is to use yet another feature in Spring Framework 6, namely declarative interface clients. So greetings client. And I'm going to create a record here called greeting string message. And I'm going to create a method that returns a greeting given a string name. So this is going to be a client that talks to our API, the one that we just finished building, but that automatically does so without our sort of having to write all that low-level REST template or web client code. I can just use this interface. So I can say get exchange, and the endpoint is greetings name. Okay, I can use these new annotations like get exchange and post exchange, etc., to describe the client characteristics. But certain annotations like path variable can be shared across both get mapping for the service side and get exchange for the client side. And now I need to turn this interface into an actual bean that I can use. So here I need to create an HTTP service proxy factory like so. So I'll say web client adapter dot create HTTP service factory for a web client. And I'll say web client dot builder var wc builder base URL HTTP localhost 8080. Okay, so there's my builder and wc. Good. Okay, there's my web client HTTP service proxy factory. Now I need to actually build a implementation of that interface. So I'll say create a bean here, I'll create a bean here of type greeting client, and I'll use that HTTP service proxy factory. Okay, create client greetings client.class, voila. And then finally, I'm going to create a bean of type application listener, application ready event, ready, return, new application listener. And we're going to inject the greetings client, GEC dot greet, and we'll say Spring fans var response. And look at that, that's another nice feature that you get with Java 17 is var. And I'm just going to print out the result of that. So response, good. It's a greeting type that we get back typed for us. I'm going to replace that with a lambda. Why not? Okay, good. So now I want to run this. Let's just run it on the JRE and see if that works as we expect it to. Okay, it seems like it's worked. Now, I want to then turn this into a GraalVM native image. Now, there's a little bit of a problem here. You see, I'm creating a JDK proxy behind the scenes when I use this, and that's going to create some issues for us. We need to actually tell GraalVM about all the use cases, all the scenarios where we do things that run afoul of its very, very particular and finicky restrictions on runtime flexibility. Things like class loading, class.forename and reflection, things like serialization, things like JNI, things like loading resources from jars and property files and icons and the like, things like proxies, all that stuff needs to be accounted for in configuration files. Now, obviously, you see that even though Spring does a lot of that stuff, it just worked right before. So for the very large part, most things are going to just work just fine. That said, in certain cases where Spring can't know what you're doing, you need to be very explicit and tell it so that it can provide that configuration to the GraalVM native image compiler. So for example, here we have a greetings client. That greetings client is going to be turned into a proxy, and then it's going to make an HTTP request and give us a return value of type greeting. So we need to register hints. These are hints. These are what we call the configuration entries that get fed into the GraalVM native image compiler, right? We're going to register a hint here by using the register for reflective binding greeting dot class. Okay, so that's one part of our problem done. The other thing is that we need to tell GraalVM about the fact that we're creating a JDK proxy behind the scenes, right? So that proxy is going to require 3 different types. Represents not just our interface, greetings client, but 3 others that the Spring proxy factory will register. So let's create a class called greeting client runtime hints registrar, and it'll implement runtime hints registrar. And we have to override this method here. And we'll say hints dot proxies dot register JDK proxy, and we're going to feed it in very particular order. By the way, here I already happen to know what it's going to require, but if you if you try and compile the application, without these hints already, it'll complain, but it'll print out on the console which interfaces need to be accounted for. It'll print them out in the order in which they need to be accounted for as well. So you can just copy and paste that, and you'll arrive at exactly the same thing as I've just done. So now we've got this registrar hints, this greetings client runtime hints registrar that we need to then tell Spring to use. So voila. Okay. All right. So now we've got our custom hints. We've got our proxy. I guess I want to then use this greetings client in a GraalVM context. So let's go ahead and compile it. This will take about a minute. All right, the application's finished compiling. Let's go check it out. Client. And there we are. There's our result, just as we expected it. It worked. It's given us a response to our query, and we can actually see that reflected in the console there. All right, my friends, we've just taken a very brief, quick, abbreviated look at a number of new features, problem details, the AOT subsystem, the Jakarta EE API upgrades, the Java 17 baseline, and of course, the declarative clients. Now, obviously, we've just begun to scratch the surface here. We could and probably will do videos detailing things like, using other time series databases and chasing with the new observability support. We'll probably do videos. We definitely will do videos looking at the new AOT subsystem because, believe me, we've only just begun to scratch the very tippity top of the surface. You don't know anything yet, my friends. It's crazy how impressive and how robust this new subsystem is. We could and probably should look at things like using other declarative clients, new other declarative interfaces for other protocols, in particular for RSocket. Because remember, this is generic, right? Conceptually, we could also do this for GraphQL, for example. There's a lot of interesting implications here. What we have out of the box, by the way, is meant to supersede the support in Spring Cloud, in Spring Cloud Square, Retrofit, and Spring Cloud OpenFane, and even that experimental project I created around RSocket support. All that is meant to be superseded by these new declarative types. So there's a lot of interesting implications here. And of course, we get new APIs. Hibernate, the latest and greatest Hibernate, the latest and greatest Tomcat and Jetty, and all these things are now accessible as part of Spring Boot infrastructure. So, a lot to look at, but we've got a lot of time, and I wanted you to be able to try these bits out and see kind of what Spring Framework itself has done for you. I've consumed everything thus far in terms of Spring Boot 3, which in turn does a fair bit more in their new upgrades. But this is a lot of this is superficial stuff that will be very interesting on the face of what you're doing. But a lot of it is also just back-end, subsystem tuning. You wouldn't believe the amount of work. Like I say, you wouldn't believe the work we had to do to make Jakarta EE and Java 17 and all these other things, and AOT, all these new paradigms, all of them work well and consistently across the project and the portfolio. Obviously, we hope you enjoy it and get something out of it as well. As always, my friends, we'll talk to you next time.